So today we're going over Chapter 9, Section 3, Similar Right Triangles. This is Theorem 9.6, and it states, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Now, the key words right here are right triangle and that it must be a, guys, I'm going to repeat this multiple times. This must be a right triangle. So, if we are able, I'm just going to restate it. If we have a big right triangle and we draw the altitude from the top of the triangle to the base, again, that would form a new 90-degree angle. So we have now three triangles. The big triangle ACD, ACD is fine. It's going to be similar to triangle BAD, which is going to also be similar to triangle BCA. Now, I want you to understand that the way we break it up, it's going to always be the same. Let's say this is a 30, 60, 90 triangle, right? When we break this into two, this is going to be the new 90, so this is going to be 60. When we break this up, this is going to be 30. So all of it is going to be similar because the angles are going to be congruent. Example 1 states, or to identify the similar triangles in the diagram. Now, we have three triangles. We have the original one, which is this yellow one I'm highlighting. Then we have this small blue one. And then we have this red one. Now, since the original is actually already has a 90-degree angle, and we realize that that is an altitude drawn, we are able to state that the triangles are similar. Now, I'm going to draw the triangles right here. So, TUS, so that's the blue one. I'm trying to draw it to the best of my abilities. RUT, and then the third triangle, it would be RTS. So the only reason I drew them like that is to be able to write the triangle similarity statement a lot easier because I can go in order. So I can say triangle TSU is similar to triangle RTU, which is similar to triangle RST. So I went TS and then U, R to T and then to U, and R to S and then to T. So it is important that you guys write it in the correct way. So now we have the geometric mean. The geometric mean is a proportion A over X equals X over B. So x squared equals AB and x equals the square root of AB. Now, so if you guys remember, proportions we cross multiply. So we're going to get x squared is equal to A times B. So we take the square root and then we get that x is equal to AB. Right? After we take the square root. So, when you're giving two numbers, square root their product. So multiply them and then take the square root. That's how you're going to get the geometric mean. Any questions, guys? Now, obviously, this is assuming you already solved it. That's how you're going to get it, but it's after you square root it. So for example 2, they want us to find the geometric mean by the given number. So let's do A. We have 4 and 20. So if you guys remember, it's going to be the product of those two numbers. So it's going to be the square root of 4 times 20. Now, 4 times 20 is actually 80. So then we get the square root of 80. Now, we do want it in the simplest form. So I'm actually going to go ahead and start doing the factor tree. Now, if you do it a different way, that is fine. This is how I learned it. So we get that the root 80 factored out is actually going to be 4 root 5. So this would be your answer at the end. Example B, again, we're going to do 9 times 25. And 25 times 9 is 225. So I'm going to go ahead and start factoring because honestly I have no idea what this is. It seems like a perfect square root, but just want to double check. So 225 divided by 5 is 45. I divide that by 5 again, and that gives me 9. So then it's 3, 3. Now, this all simplified to a perfect square root, so I can take the pairs out as a 5 times a 3, so we get that this is a perfect square root of 15. Now, obviously, when you guys get to use your calculators, if you don't have them already, you can just type 225 and take the square root, and then it should be able to give you that it's a perfect square root of 15. But since it doesn't factor down the radicals, you do need to know how to simplify them in the case that your calculator won't give you a final answer. Here we have theorem 9.7, which is the geometric mean altitude theorem. So it has two things. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the length of the two segments of the hypotenuse. So what does this mean? This is the same thing as you guys had before, the a over x equals x over b. But instead of having a and b, we have segment 1 and segment 2. And then the altitude is the x, which is the thing they both share. But it's still the same formula, just they changed the names of the letters into segment and altitude. Now, here we have theorem 9.8, which is the geometric mean, but instead of with the hypotenuse, with the leg. So in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So A and B are segment 1 and segment 2 from the previous slide. And the length of each leg of the right triangle is a geometric mean of the length of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So guys, we're using the exact same formula, but instead of doing a segment or a leg and a leg, well, not a segment, we're using x, y, b, and a. And, well, a and b is, the entirety is c. I don't know why it's not written down there. But I want you to realize a and b is the hypotenuse of the big triangle. So hypotenuse in this case would be c. We have the legs, which is going to be x or y, depending on the order that you want to put it. And then you have the segment adjacent to that leg. So if it were to put x, you would have to put a. If you would have used y, you would have to choose b. So if you notice, we have c, the hypotenuse, x, x, so the same one, and then a, which is right next to it. Or if we use y, we have, again, the c, which is the hypotenuse, y, y, and then b, which was the one adjacent. So it doesn't matter what leg you use, as long as you are consistent that if you use the leg on the left, you have to use the segment that's adjacent to that leg. And if you use the one on the right, you have to use the segment that's adjacent to the right. They are. Now we have example 3. They want us to A, if JR equals 16, so JR equals 16, so this one right here, EJ equals 9, and HJ, oh, they want us to find HJ RE, so HJ I'm going to call it X, RE I'm going to call it Z, and HJ, RE, so RE is this whole segment, are HY and HEZ. Okay. Sorry guys, I was skipping one of them on accident. So they want us to find all of that. Now, the simplest section to find is actually RE because it's just 16 plus 9. So we get that the whole thing is 25. But if you notice, that is the hypotenuse. So we can actually use that in order to solve for it. We can do either the segment over the altitude equals the altitude over the segment, let's use that for the x, to find x, which is the altitude. So the segment, I'm going to do 9 over the altitude x equals x over the other segment, which is 16. I'm going to cross multiply, and I'm going to get x squared equals 16 times 9. Now 16 times 9 is 144, so I'm just going to go ahead and write it in. Now, and 144, when we square root it, is a perfect square root. That's 12. So we get hj is 12. Now, in order to solve for y, I'm going to use the hypotenuse leg. So hypotenuse leg equals leg over the segment adjacent to the side. So I'm just going to write segment adjacent to the side. Well, actually, I shouldn't write SAS. I'm going to write I'm just going to write S. You know, it makes it easier. The segment adjacent to the side. So the hypotenuse, 25, equals, I'm going to solve for y first. Why not? Y equals y over that segment adjacent is 16. I'm going to cross multiply, and I'm going to get y squared equals 25. So 25 times 16, and 25 times 16 is actually 400. So I'm just going to go ahead and erase 25 times 16 and write in 400. You take the square root, and guys, this is actually a perfect square root, so we get that y is actually equal to 20. So HR is actually 20. And we're going to have to do the same thing for the z. We can do hypotenuse 25 equals z over 9. So we get z squared equals 25 times 9. And 25 times 9 is actually 225. And if you guys remember from the previous example, we already solved this one earlier. So we know this is actually just supposed to be 15. So our HE is 15. That's how we solve for the first part of this triangle. I'm actually, instead of erasing all of this work, I'm actually just going to go ahead and add a new slide. Now, the slide is blank. I'll redraw the triangle to the best of my abilities so you guys have it. So H, J, E, R. And they're telling us if JR is equal to 4, JH is equal to 2, they want us to find BJ. I'm going to call that X. They want us to find RE, so this whole thing. They want us to find RH. I'm going to call that Y just to keep it with the same one. And they want us to find HE. Again, I'm just going to call it Z just to keep going with the same example. Now, plugging that in, I'm going to go ahead and solve for X first by doing the segment 1 over the altitude equals the altitude over segment 2. So segment 1 is X. So X over the altitude, which is 2, equals 2 over the other segment, which is 4. I'm going to cross simplify, and I'm going to get 4x is equal to 4. Then I divide it by 4 on both sides, and I get that x is equal to 1. So EJ is just 1. I'm actually able to find RE because it's just going to be 4 plus 1. So 4 plus 1 is 5. So RE is 5. Now I'm going to actually have to use the hypotenuse over leg equals leg over the segment, the segment that's adjacent to the leg. I'm just going to call it S. So when I do that, I'm going to go ahead and solve for y first because it's RH and it's the one next on the list. So when I do that, I'm going to set it up as 5 over y equals y over 4. I'm going to cross multiply, and I'm going to get y squared is equal to 20. Now 20 is not a perfect square root, so I'm going to go ahead and factor tree it. So I'm going to get that y is actually equal to 2 root 5. So RH is 2 root 5, 2 root 5. Now HE, I'm going to erase the hypotenuse leg one, the formula, just so I can solve for it. And HE is Z, so we're going to use the same hypotenuse, leg, segment, adjacent. So it's going to be 5 for the hypotenuse, Z equals Z over the segment, which is 1. I'm going to cross simplify and get square root Z squared equals 5. I'm going to take the square root on both sides, and I get that Z is actually equal to the square root of 5. We can't simplify it anymore, so that would be our answer, root 5, root 5. So that is it for today's notes. You guys do have homework on Canvas. But that's it for today.